Hey mathematicians, this is just going to be another quick video. If you need help with this starter, looking at the first question, they're giving you this equation to graph. This is the line y equals 2. If x equals a number is horizontal, vertical, then y equals a number is going to be this horizontal graph. So in terms of adding to your notes, you may want to write that down. Y equals a number is the graph of a horizontal line. And in this case, this would be then the horizontal line where y is equal to 2. Right? At any of these points, y would be a value of 2. I could put a point anywhere on this line. All of them have a y value of 2. In the case of the x-intercept, this one's going to be a none because it doesn't cross the x-axis. And its y-intercept is hanging out right here as an ordered pair. That means an x comma y value. This one is the ordered pair 0 comma 2. Looking at the next question, this is the same kind of question, but instead of that horizontal line, now we've got this vertical line. X is equal to 3. If I wanted to graph that one, I could go to any points where x is equal to 3. The y values do not matter. So in this case, this one does have an x-intercept, right? Because x equals a number is going to be a vertical. All the x's are in common. If I put points anywhere on this line, they all have an x value equal to 3. So in this case, the y-intercept would be the one that is none because it doesn't cross the y-axis, and its x-intercept would be 3, 0. Right, that's where it crosses the x-axis. So the y value is 0, but the x value is 3. For the next question, for this one, just linear intercepts. So if we know that it's an x-intercept when it crosses the y-axis, right, this means that, the x-axis, that means y is equal to 0. It's a y-intercept when it crosses the y-axis, so the x is equal to 0. We're going to plug these points into the equation and then solve. So to get the x-intercept, we could do 3x minus 5 times 0. That has to equal negative 15. In this case, then 3x has to equal negative 15, right, because the 5 times 0 is going to cancel out. And then I can just divide by 3 to get that my x has to be negative 5. But I do have to write it like an ordered pair, an x comma y. So in this case, my y value was 0, and my x value is negative 5. So negative 5 comma 0. Going down to my y-intercept, that's this time plugging 0 into the x position. So 3 times 0 minus 5y has to be negative 15. In this case, my 0 cancels out, so negative 5y has to be equal to negative 15. If I divide by negative 5 on both of these equations, I get y is equal to positive 3. So writing that one as an ordered pair, my x was 0 and my y was 3. Looking at this last question, oh gosh, this is a Burley starter. It's a Burley unit in that way. So looking at this one, we had this one in our lesson yesterday. That double distributive property means that I have to distribute the x, and then I also have to distribute the 5. So distributing the x, in that case, my first term is going to be my x times x, so x squared. Then I do x times 5, so that's my 5x. Distributing the second term, right, that's the idea of the double distribution. 5 times x would be 5x. 5 times 5 is 25. If I combine the 5x's, my trinomial would be my x squared plus 10x plus 25. So, doing that same process with these next problems. For the first terms here, I get my x squared and a 6x. In this secondary distribution, I get a 6x and a 36. So my trinomial is x squared plus 12x and then plus my 36. My next one, I would just first rewrite it as x plus 2 times x plus 2. If we're noticing our pattern here, right, with our double distribution, we get an x squared plus 2x and then another 2x and a 4, leaving us with x squared plus 4x plus 4. Yep, that one's right. And then this last one, again, we could rewrite, but hopefully we're starting to notice the pattern, which is really what the last question is going to ask about. So in order to get our first number, we're going to get that x squared. Then we're going to have an 8x and another 8x, so that's 2 times that middle number. So that would be our 16x. And then our last number is going to be 8 times 8, which is 64. So I think the last question asks you to write it in general. If we have x plus p squared, how could we get our trinomial? We would have x squared plus 2 times p with an x, and then plus our p squared at the end. So this is like our hack, I think, for part E for this question. Yeah, so in terms of p and b, our expression for b in terms of p. If I pull that back up, well, we could just do it again. In this case, right, our x plus p squared, we would have our x squared plus our 2p times x plus our p squared. And then it's asking, how do I get b in terms of p? Well, it's an ax squared plus a bx plus a c. In this case, my b is 2p. It just wants an expression. I was going to write it as an equation, b equals 2p. But they just want the expression, so my guess is they just want the 2p. All right. If you needed help with this starter, hopefully this video helps.